Hi, today I'll be showing you my project, which is to build an unprotected web server and analyzing a server using Amazon Web Services. So to do this project, there's a few steps. First of all, we need to create and set up an AWS account. We do that by creating a user, creating a group, creating a role, and adding the correct policies to it, as you can see in the video right now. At this point, I am adding a special policy for Cédric, which is the system I use to help me monitor the state of the server. So what I'm doing here is adding a special policy that allows Cédric access to the server so I can get the monitoring data that I need. Next up is creating an EC2 instance that is running Amazon Linux, and also to set it up so that it allows all traffic from all ports. Again, I'm going through this process quite fast because it's just using the default settings, except at this point where you can see me configuring the network settings to allow all traffic from all ports and calling it no security. After I do this rule, you can see that it is giving me a warning that this is not a secure way to set up the server, which is exactly what I want. As you can see now, it is asking me for a public key pair that I still need to create, which I'm doing right now, in order to authenticate my login to the server. So by default, it isn't allowed to log in by using a password. Next up is to create an S3 instance where I can save the logs to. An S3 instance is basically a storage server, which allows me to collect data and save files to. I'm doing this in case that my server that is running Linux gets affected and the logs get deleted. I want to have a backup on this server. Finally, we need to connect to the Linux server and configure a terrible security setup. So first of all, what I will be doing is I'm logging in and I'm setting the passwords for both root and EC2 user to password. Then next, I need to go into the sshd.config file and allow password authentication and also allow root login. And then finally, all I'm doing is installing the packages for Cédric monitoring. And finally, I'm giving in the command to start Cédric logging. Now that we have an unprotected server set up, all we need to do is wait and be patient and hope that we get hacked. So 14 hours later, I managed to see in the monitoring tab of the AWS overview that there has been some activity. First of all, you can see that there has been a huge spike in CPU usage around midnight. This CPU usage almost reached 100%. Another thing that we want to see is that the networking out also has received a huge spike. When we were looking at the numbers, you can see that they're not that high. It's the same for the packets, so the number of packets going out has also increased, and there has been a very small spike in the network in. So we continue now by checking the logs of Cédric, in which we can see the CPU usage per process. Just looking at the big spike there, we can see that it has been using Perl, which is weird because I did not install Perl on the server. Same for this second graph, there's a small pink spike there with Perl doing it. It's the same for the networking, so there's also a small networking amount going to Perl, but the biggest thing that we can see is that the number of network connections per second that I have suddenly spikes to almost 250. You can also notice that in the file writing, there is suddenly a spike in writing the Cédric file. That means that there will be a lot more activity that needs to be logged. So there will be something interesting in the logs there, hopefully. Finally, we're going over to actually analyzing the logs that we have instead of looking at the graphs. To do this, I have imported the logs into a Linux system that has Cédric installed, and that way I can analyze it. So first up, we will check the top network using processes. As you can see at the top, it's Dragoned, then it's Yum, which is normal because I installed programs with Yum. And then you can see a few instances of Perl. There's about 4 instances in the list and they're not using that much data. The next thing I want to take a look at is the top connections that have been made. So which processes used which connections, to what IPs that they connect, which port that they use, and so on. So we use our different ports to connect to the same IP address using HTTP or HTTPS. So at this point we have established that we have a high CPU usage, a low network usage, Perl is being used, and apparently we are sending packets to random IPs over different ports. So let's go a bit more into detail and see exactly what happened on this computer or on this server. To do that, we use the spy users command, which allows me to see all the commands that have been made while I was logging. I am now highlighting the bits of the commands that I did not do. So we can see in the order the commands that he has made. First of all, he installed Perl. Then he made an invisible user called user. He downloaded a file from GitHub user content, which is called slowloris.perl. He renamed it to a hidden config file, which is called .config.config. He used Perl to run the script with different settings, and finally he removed all my logs and made new ones instead. Alright, so what's left to figure out is to see what the slowloris script is and what it does. So just to go over this again, he managed to log into my server, he installed Perl, he downloaded slowloris, he ran the script, and then he cleared my logs. So what is slowloris? So according to the file that is on GitHub, slowloris is a low bandwidth yet greedy and poisonous HTTP client. As it says, it has low bandwidth, which we've noticed, and it is using a lot of CPU to do something with HTTP requests. So let's continue our research a bit more to see what exactly slowloris is doing. And if we look at Wikipedia, we can see that slowloris tries to keep many connections open to a target web server and hold them open as long as possible. It accomplishes this by opening connections to a target web server and sending a partial request. Periodically, it will send subsequent HTTP headers adding to, but never completing, the request. That way, the affected server will keep these connections open, and those connections that are doing nothing will fill their maximum concurrent connection pool. To end with, I also have received a nice email from Amazon to notify me that my server was doing abusive requests to another different server, and if you look at the mail, you can see that it has been a denial of service attack used on a system that I own. Well, this was my project. Thank you for watching, and I hope you learned a thing or two.